Okay, so here, this is one example from your problem set. Two molecules here, same number and types of atoms. Okay, now what we see here is a difference in melting point. Right here, where our melting point is 45 degrees Celsius. Here it's 115 degrees Celsius. Okay, so what we know from that is that there's more interaction between these molecules here on this side than there are this side. Okay, so let's look at what goes on. I know you guys have seen this before, but if we don't write it, what we have here, all of these guys are carbons, and there are double bonds here between some of them, single bonds between other ones. Okay, and this nitrogen is really a nitrogen with two oxygens and non-bonding pairs as well. Okay, so this molecule, what happens here is you have a slight dipole here on this hydroxyl group, this OH group. Right, so you have a slight negative there, a slight positive here. There's a slight negative here on this. So what you do get is you do get some hydrogen bonding here between this hydrogen and this oxygen. Okay, this would be an intramolecular hydrogen bond. Okay, but because of this, that neutralizes some of this positive charge here, so this is not as available to make a hydrogen bond with another molecule, right? And really what we're interested in here is the ability to hydrogen bond with another molecule. If you look here, you have your oxygen with two lone pairs, your hydrogen, your slightly positive hydrogen, all right, and that can interact with another molecule with the slight negative on another molecule if this is attached to another ring over here, okay? This can donate a hydrogen bond here. Another one can come over here and hydrogen bond here. So there's a lot more potential. You can get, right, another molecule here with a ring bonding here. So there's lots of potential for hydrogen bonding in between molecules. Here the hydrogen bonding is mostly within one molecule. So therefore it takes a lot less energy to melt this substance than it does this one. Okay, I'm going to go through another example here. Give me a moment. Okay, here's another example. All right, so these are, again, two compounds, same number and types of atoms. This one here has a boiling point of around 34 C. This one is around 117 C. Okay, so again, with these dipole interactions, you have a slight negative charge here on your oxygen. So this can accept a hydrogen bond, right? Because it's a slight negative charge. The problem is there's no positive for it to pair with. Okay, so you don't get intermolecular hydrogen bonding here. Whereas one butanol can, and does, if there's a bunch more carbons here, can make a hydrogen bond with several other butanol molecules. Okay, so this one butanol molecule is hydrogen bonding to another and another. Okay, and those forces holding it together, those attractions, increase the boiling point. So that's why we get a difference in boiling point there. Okay, and everything we said before about dipoles works too, right? In the sense that we have we have bond dipoles here between the carbon and the oxygen, but they're the same magnitude and they cancel out. Whereas here, the bond dipole is pointing in one direction. Okay. Most of the rest of the stuff was based on electronegativity differences. I think you guys should be able to get through it. And we'll keep working on this. All right, hope that helps.